This is Banza Academy. Today we will familiarize ourselves with the new requirement elicitation technique. Let's talk about prototyping. The prototyping elicitation technique is a user-centered approach used in the field of software development and requirements engineering to gather and refine requirements for a system or software application. It involves creating and presenting prototypes of the proposed system to stakeholders, such as users, clients, and developers, in order to elicit their feedback and requirements. By the way, a user-centered approach is a design and development methodology that places the needs, preferences, and behaviors of the end users at the forefront. It involves understanding the user's goals, tasks, and challenges, and using this knowledge to inform the design and development process. The technique of prototyping involves capturing user interface requirements and merging them with other requirements, including use cases, scenarios, data, and business rules. It has been widely acknowledged as an effective approach for designing products, as it allows for a visual demonstration of the product's appearance and functionality during the initial stages of design. Prototypes can take the form of functional representations showcasing a potential solution, proposed product, or service. There are different prototypes. Some describe the general logic of the system, while others focus on the nuances of a particular area. 1. Horizontal prototyping. A horizontal prototype provides a wide-ranging view of a system's functionality without the inclusion of intricate business logic. It aims to showcase various features and interfaces across the system, allowing stakeholders to gain a comprehensive understanding of the overall scope and breadth of the system. 2. Vertical prototyping. In contrast to horizontal prototyping, a vertical prototype focuses on a specific area or subset of a system's functionality in depth. It delves into the finer details and intricacies of that particular aspect, providing a more comprehensive and detailed representation. This type of prototyping allows stakeholders to gain a deeper understanding of a specific feature or module within the system. Also, the prototype may eventually grow into a full working system or remain in existence, for example, only on wallpaper. Evolutionary prototyping involves gradually expanding and refining a prototype into a fully functioning system. It typically starts with a basic prototype that demonstrates core functionalities and user interfaces. As the development progresses, additional features, functionalities, and refinements are incrementally incorporated into the prototype, resulting in an evolving and more complete system. This approach allows for iterative feedback and adaptation throughout the development lifecycle. Throwaway prototyping, as the name suggests, involves creating prototypes that are not intended to be part of the final system. These prototypes are typically developed using simple tools, such as paper and pencil or low-fidelity mock-ups, and are used to quickly explore and clarify interface requirements. Once their purpose is served, these prototypes are discarded, and the final system is implemented separately based on the insights gained from the throwaway prototypes. Prototyping can be done at various levels of detail, depending on the stage of the design process and the specific goals of the prototype. Here are the common levels of detail in prototyping. 1. Low-fidelity prototypes. These prototypes are simple and basic representations that focus on conveying the overall structure, layout, and flow of the design. They are typically created using low-tech tools like paper, sketches, or digital wireframing tools. Low-fidelity prototypes are useful in the early stages of design for quick ideation, exploration, and feedback gathering. 2. Medium-fidelity prototypes. These prototypes provide a moderate level of detail, adding more visual and interactive elements compared to low-fidelity prototypes. They often involve digital mock-ups or interactive wireframes that simulate the user interface and basic interactions. Medium-fidelity prototypes strike a balance between speed of creation and level of user engagement, allowing for more comprehensive usability testing and gathering more specific feedback. 3. High-fidelity prototypes. High-fidelity prototypes are more refined and closely resemble the final product in terms of visual design, functionality, and interactivity. They are typically created using specialized prototyping tools or development frameworks. High-fidelity prototypes provide a realistic representation of the user interface, including visual aesthetics, interactions, and sometimes even real data. To determine the prototyping approach, it is important to consider the goals, requirements, and constraints of the project. Different prototyping approaches can be employed based on the specific needs of the development process. Some common approaches include horizontal, vertical, evolutionary, and throwaway prototyping, as mentioned earlier. Once the prototyping approach is selected, the next step is to identify the functionality that needs to be modeled. This involves determining the core features, workflows, and interactions that the prototype should represent. It is crucial to involve key stakeholders, such as users, clients, and subject matter experts in this process to ensure that the identified functionality aligns with their needs and expectations. Requirements gathering techniques, such as interviews, surveys, and workshops, can be used to gather information about the desired functionality. Use cases, scenarios, and user stories can also be helpful in defining and documenting the specific functionality to be modeled. The goal is to capture a clear understanding of the system's requirements and translate them into the prototype's features and behavior. Building a prototype is an iterative process that involves gradual refinement and expansion. To begin, it is important to outline the high-level views and concepts of the prototype. This initial phase focuses on capturing the overall vision and key functionalities of the system. It's important to note that the prototyping process is often an iterative one, with feedback and insights gained from each iteration informing subsequent refinements. The number of iterations will depend on the complexity of the project and the level of validation required. Iteratively refine and enhance the prototype based on the collected feedback and insights. When it comes to prototyping, there is a wide range of tools available to suit different needs and preferences. Let's explore some commonly used tools for prototyping. 1. Low-tech tools. The simplest and most basic approach involves using paper, pens, or pencils to sketch out rough prototypes and interface designs. This hands-on method allows for quick ideation and iteration. 2. Wireframing and mock-up tools. These software applications enable the creation of visual representations of a user interface. Wireframing tools like Miro, Axure R, P, and Sketch are great for creating basic layouts and structures. 3. Prototyping tools. Building on wireframes and mock-ups, prototyping tools take things a step further by allowing you to create interactive and clickable prototypes. With tools like Adobe XD, InVision, and Figma, you can create prototypes that simulate user interactions and demonstrate the flow of the application. 4. Development tools. For more advanced prototyping needs, coding and development tools can be used. This involves using programming languages, frameworks, and libraries to build functional prototypes. HTML, CSS is commonly used for web prototypes, while languages like Python or JavaScript can be used for creating interactive prototypes. Prototyping goes beyond simply creating a representation of the product to be. It should also focus on eliciting the desired user experience. The goal of the prototyping process is to evoke a multi-dimensional and immersive feeling that aligns with the intended target experience. By considering the user's perspective, prototyping can capture not only the visual and functional aspects, but also the emotional and experiential dimensions. This involves crafting the prototype in a way that engages users and allows them to interact with it as closely as possible to the final product. Utilize the prototype as a tool to validate and assess design decisions, user interactions, and system functionalities. Engage stakeholders to gather valuable feedback that helps identify any gaps or areas requiring further refinement. This iterative feedback loop aids in enhancing the prototype's effectiveness and aligning it with user needs and expectations. Finalize and document. When the prototype has successfully achieved the desired goals and requirements, it is important to finalize the prototype and document the key findings and design decisions. This documentation serves as a valuable resource for future reference and development stages. During this phase, carefully review and validate the prototype against the defined objectives and requirements. Ensure that it accurately represents the envisioned solution and addresses the identified user needs. Make any necessary refinements or adjustments to align the prototype with the desired outcome. Let's summarize and weigh up the advantages and disadvantages of the prototyping technique. Advantages: early validation. Prototyping allows for early validation of design ideas, concepts, and functionalities. By creating a tangible representation of the product or system, stakeholders can interact with it, provide feedback, and identify potential issues at an early stage. Iterative improvement. Prototyping facilitates an iterative approach to development. Through multiple iterations, feedback is gathered and improvements are made based on user insights. Enhanced collaboration. Prototyping encourages collaboration and communication among stakeholders. By visualizing and experiencing the prototype, stakeholders can effectively communicate their ideas, requirements, and concerns. Disadvantages: time and resource intensive. Prototyping can be time-consuming and resource-intensive, especially if multiple iterations and refinements are required. Building and testing prototypes may require additional effort, expertise, and tools. Scope creep. Without proper business analysis information, prototyping can lead to scope creep, where additional features and functionalities are continuously added to the prototype, extending the project timeline and increasing costs. Potential misinterpretation. Prototypes are representations of the final product, but they are not the final product itself. There is a risk of stakeholders misinterpreting or overgeneralizing the prototype's capabilities, leading to unrealistic expectations or misunderstandings. Thank you for your attention and see you in the next modules.